Hey guys, this is Geometry 8.4 Inscribed Angles. You will have a little bit of homework tonight, but I wanted you to do some of the even numbers, so you won't be able to check it just by using your book. So at the end of this video, I am going to go over the answers, so I'll trust that you will pause the video, stop the video, go do your homework, and come back and watch the end, get the big reveal, okay? Alright, Inscribed Angles. Anybody think my handwriting on this is getting, not any better? I think that's about as good as it's going to get, guys. So, we'll deal with that. Okay, inscribed angles. Inscribed angles are angles whose vertex is on the circle, okay, and whose sides are chords. So, there's a vertex of some angle, and it's on the circle, and the sides are chords, which means their endpoints are also on the circle. So, there you go. There's an inscribed angle. You could also have one that looked like this, a lot wider. Also an inscribed angle. You could have one that goes right through that, the center. That's also an inscribed angle. Okay? They could be really, really, really tiny. Still an inscribed angle, okay? All right. Now, the neat thing about an inscribed angle is that the measure of the angle is half of the arc length that goes across. Now, I know we talked about arc length being measured in inches or in centimeters or something like that. That is when we knew the radius, okay? Now that we're getting to angles and the relationship between that and the arc length, we are going to just refer to some things as the arc itself, and that will be this part out here. And this will be the inscribed angle, meaning some degrees. So we're not always going to measure it in inches or something like that. Your book refers to it as degrees. I've not seen it as degrees. I've seen it as just your number that goes along with it, but it's a relationship or in proportion to. Now, it's not really how far across it is because we don't have a radius, but that's how we're going to refer to that arc length. So hopefully that makes sense. We'll kind of go over some of that as we practice some, okay? All right, so one of the unique properties that we know, there's three things I guess that was one, so 4 things that we want to talk about. So, before we go on, let's practice one of these. Let me just give you an example. Okay, so here's some circle. Okay, there's its center. We'll call this circle C. And we are going to have some inscribed angle right here. And if I told you that this angle measure was 30, can we find the measure of the intercepted arc, or the measure of this arc out here? Could we find it? Yeah, remember, we know that the measure of the angle is half of the measure of the arc, right? Measure of the angle is half of the measure of the arc. So if this is 30, that's half of some number out here. Well, what's twice of 30 if you want to work backwards, right? This should be 60. Now, your book refers to it in degrees. You could also just use a number, and that refers to the intercepted arc. Remember, that's not in inches, not in centimeters, anything else like that, because we don't have a radius. But we still need to be able to identify what's kind of going on, okay? So we'll call that 60. What if I gave you another one? What if I said that I have this inscribed angle, and I actually know the intercepted arc? I know that this is, let's see if we can make this logical. Let's call this 90. Well, the inscribed angle is half of the arc, inscribed arc. So if that's 90, then this measurement in here of the yellow angle would be 45, or half of it. Okay, I know it's starting to get a little messy. Does that make sense? Okay, a unique property that we could kind of conclude is if we have an a circle, and if they all, I have 3 inscribed angles here, right? I have this red one, I have the black one, and this teal one. If they share their intercepted arc, it doesn't matter what number you would put with this, right? That would go with it to define it. We know that these angle measurements all have to be the same. They're all going to be equal to each other. And same goes if you had some arcs or some I guess just inscribed angles. Let's say if I knew this was 20 degrees, and let's see if we can kind of make this happen here. Then if these share the same endpoints here, if it's an inscribed angle and it shares the intercepted arc, then this guy over here, which is now starting to get really crowded, sorry, I'm going to kind of just see if I can't shade this whole guy. And this guy here, this measurement would also be 20 because they share this intercepted arc. Okay? All right, so a couple other things here. Okay, so one of our other theorems here is going to be if I have some angle inscribed inside of a semicircle. So let's say here is my circle. This half is the semicircle, right? This entire section, because it's half of the circle. Okay, now I'm going to need to inscribe an angle inside this semicircle. That means my vertex can be anywhere here, and my other endpoints need to be here. No matter how I create this, it's always going to be a right angle. Any inscribed angle inside of that half of a circle or the semicircle is going to be a right angle. Okay, so I could come way over here and it's still a right angle. Okay, any vertex that you choose, no matter where you pick, is going to still create a right angle. Okay, that's a really neat property about having some angle inside of a semicircle. So you're going to have a lot of things. This book, as we know, kind of goes through things in a lot of depth quickly. So even if you had something like this, and maybe you had something like this here, like you've got to be able to identify real quickly, hey, if this is a straight line, I'm recognizing that I should see a semicircle. So if there's any other arc, I know already that's a 90-degree angle. Apply the Pythagorean theorem if you need to. There's a lot of things that can happen just directly from that information. Okay, and the last one, if I had, I suppose I should undo this here. If I had this is a inscribed angle, right? Vertex on the circle, endpoints on the circle. What if I had another inscribed angle who shared some endpoints here? What have I created inside of my circle? Why, yes, a quadrilateral, right? 4 sides, 1, 2, 3, 4. This could be shown in many different ways. It could be something that looks very cookie cutter, kind of like I showed you there. It could even be a square, right? But you could also have something that looks a little bit crazier. You could have, this is an inscribed angle here, and I could have something like this, right? They share those endpoints. Maybe this is a semicircle. We don't really know. But this is still a quadrilateral, okay, as long as it has the 4 sides. And something that we can identify in a quadrilateral, if you have a quadrilateral that's inscribed, that means just inside of your circle, let's see, I'm going to undo this a little bit here just to make it a little bit bigger for what I'm doing. Any of your opposite angles are going to be supplementary, okay? So this angle is opposite of this angle. Let's kind of give this some names here, okay? So angle A is opposite of angle C. So angle A and angle C, I should not put one mark here. I suppose they're not going to be equal to each other, but they are supplementary, right? Do you remember what that means? You guessed it. They add up to what? Oh, that's complementary. They add up to 180 degrees. Okay, so whatever angle A is, I can figure out what angle C is. And if I know that, then I can figure out some other stuff here too, right? If D and B are opposite of each other. Let's see, I'll put 4 marks there. So angle B and angle D are also supplementary, right? So they will also add up to 180. So what if I told you that I had some quadrilateral, or maybe I just have some circle here. I won't even tell you that much, right? Some circle here, and I have points A, B, C, and D. All right. What if I told you that I know some angle measurements here? What if I told you that this was, it doesn't really look it, but let's call it 100 degrees. What else could I figure out from here? Angle C, or angle BCD, however you want to write it, is going to be equal to 80, right? These opposite angles are going to be supplementary. They have to add up to 180. Okay? What if I told you D was 77? Well, what is the opposite angle? Angle B, then, would have to be 103. All right, make sense? Okay, hopefully your homework is not too tricky, but before you jump to it, I do want to just kind of point one more thing out. We've been talking so much about our inscribed angles here, this yellow angle, whose vertex is on the outside of the circle, that I just want to remind you that is different than the other angles we've been talking about. If it goes through the center, that's called a central angle. The yellow ones that we've been talking about tonight, or today, excuse me, whenever you're watching this, are inscribed angles. Okay, so note that. I want you to jump to your homework. You should be able to find this on Renweb, but I'll give it to you right now because I'm going to need you to pause the video and we will go over the answers. But this is 8.4. You need to do numbers 1 through 4, 8 through 10, and 24. So pause the video, stop the video, go try these, and come back, pick up at this point, and we will go over the homework. Okay, how'd you do? Hopefully you still have your book open in front of you. If you don't, please go get it so that you can follow along with me. Hopefully it's not first thing in the morning for you like we had when we were at school and y'all are still sleeping through it. So take a second, go get your book, open it up so you can see the pictures of me. I'm not going to draw them all for you. Circles are not my friend in terms of my drawing ability, if you recall. So, all right, number 1, what type of angle is W? Well, it doesn't have a vertex on the circle. It has a vertex in the center. So we just talked about that. This is called a central angle. Or what about angle Z? What is that? Well, its vertex is on the outside or the rim around the circle. So that's called an inscribed angle. Number 3, find the measure of angle W and the measure of angle Z, both of what we just talked about, if that arc, I will kind of sketch this out, I guess, so I can point at it. If this arc here is 86, and they're referring to it as 86 degrees, remember we talked about this is because we don't have a radius. We know that this is in relationship. That's 86. Okay, now if you can remember way back for Easter, an angle that has its center point in the middle is going to be equal to its arc measure here. So this is just going to be 86 degrees. But when we had their inscribed angle, my angle was half of that arc. So half of that, write this out. So measure of angle W is equal to 86, and the measure of angle Z, I should label that, would be half of that, or 43. You can put a degree symbol if you want. I'll take either one. Okay. All right, let's jump to number 4. What about the measure of angle W and Z? Same things. If now we know this isn't 86 anymore, But what we do know is this red part, all the way from here, the other part of my arc. You can have an arc that goes the other way around, right? All the way around together should be 360. Remember, these kind of are in relationship with the degrees all the way around. So if I know that this red portion is 278, well, what is 360 minus 278? Would that be 82? So we know this angle, or this section here that's left over, is 82, which makes this angle inside 82, and this one half of that, right? So the measure of angle W in this case for number 4 would be 82, and the measure of angle Z would be half of 82, or 41. Alright, let me know if that's not making sense. Hopefully, as we practice some more, it'll kind of come together a little bit. Alright, let's jump to 8, 9, and 10, and then we have to jump to 24 also. Alright, number 8, the measure of angle 3 is equal to 25. So find the measure of arc DC. Well, arc DC goes with, if you're looking at your book here, like I asked you to, it is the inscribed angle, right? Alright, so it's going to have to be, if angle 3 is equal to 25, the arc is twice that, right? So its measure of DC, arc DC, is going to be 50. Number 9, what if we had now we know the arc, right? We know the arc AB is 130. Find measure of angle 2. Well, that's if this is 130, and here's my angle measurement here, pretend this is the whole circle, I guess it would have to be inscribed. There we go, pretend that's a circle. It's going to be half this time, goes the other way. So the measure of angle 2 would be half of 130, or 65 degrees. Alright, and number 10. The measure of angle 3 is 28. Find the measure of angle 4. Well, I will kind of draw this out again. What do we notice about those two angles? I mean, we don't know what their arc measure is, so how does that even help us? So here's 3 and here is 4. What is similar? What do they have in common? Yeah, they share this arc, this, I guess we could just call it the intersected arc here. So that means that their angle measurements are the same. Do you remember when we had this picture? Oh, this picture here? Okay, we really scribbled over it, so you probably won't remember that. Anyway. Alright, so if the measure of angle 3 is equal to 40, what did it say? Measure of angle 3 is 28. Then the measure of angle 4 is also 28. Now we do need degrees because we're talking about measures here. Alright. Last but not least, we have number 24. And what you should notice there is we've got a quadrilateral sitting inside that circle. So they're opposite angles. Their opposite angles across from each other are supplementary. I don't know if we actually need that for this though, because what we have for number 24 is we have a unique angle. It's RQT is what we're looking for. Find the measure of angle RQT. Well, this side of my inscribed angle, it's really a triangle inside here. If this is my inscribed angle, its endpoints are on the end of a half circle, or the whole thing is inside of this semicircle. Which means this automatically, do you remember, has to be a right angle. So we really don't even have to do any math with that. Just the measure of RQT is equal to 90 degrees. Alright. If you did not understand some of these, go back, practice a few, go on to afterschoolhelp.com. Sent an email out about that yesterday, or I guess whatever day you watched this, a couple days ago, on Wednesday. Hopefully that will help you. Get some more practicing, get some more examples, and we will continue next week. Have a great weekend. Miss you guys.